Hello there. Today we're going to look at our first flip video, and just want to tell you guys that when we're doing these flip videos, you can pause them, you can rewind them, you can listen to me as long as you can tolerate if you don't understand, and you're just going to fill out your form that looks just like this. It's your notes, just like you've always had. And if you have any questions the next day, you ask those, and then we're going to work the problems, the practice problems in class. I think you'll like it. I hope so. I know my kids did last year, so let's just get right in there and see. Okay, your notes for today, we're on, it's actually looking at the properties of exponents in section 3.2 in your book. And these properties, they're not anything that's new or strange. They come from what we do with exponents, so they're just basically shortcuts, these properties. So the first one, and you may not be able to see very well on the board, I'll write bigger, but this is the exact paper that you have in front of you. There's just one change down here, and I'll tell you when we get to it. Okay, so multiplying powers with the same base. So when we multiply, we've got 3 squared times 3 to the 3rd power. And just like we did on our little project that we did the other day with your partners, and you had to take them home, we're going to write that out as 3 squared is going to be 3 times 3. And then times, that's the times that's in the middle of the 2. And then we have another one that has the same base, and it's 3 to the 3rd, so that's 3 times 3 times 3. So if we count that all up, that's going to be 3 to the 5th power. And I don't have room to write that. I'm just going to write it down here. Just want to write it big. So if we count them all up, 1, 2, 3, 4, 5, we have 5 of them. And you discovered the other day that if you're going to take these two exponents and you're going to multiply all those bases out, what you're really doing is just counting up all those bases. So that's going to be the same thing as 3 to the 2 plus 5. That's just a shortcut to add the exponents to see all those 5 bases. So 3 to the 2 plus 3, not bad. So 3 to the 2 plus 3 would be 3 to the 5th power there. So we can generalize in algebra and just say anytime we have 2 of the same bases, and I'm just calling those bases b, all we have to do is take that base and then add the 2 exponents. So it's going to be m, b to the m plus n. And then we come over here in words to multiply powers with the same base. They both have the same base here, and they both have the same base here, and that's the only time this works is when they have the same base. Keep the base and add the exponents. It's a shortcut. Okay, so now if you need to pause and go back and look at that, you may. I'm going to go on to dividing now. Dividing powers with the same base. Now we haven't done this yet, and I'm going to go shut the shade real quick. While we look at the first one, it's 5 squared over 5 to the 2nd power. The morning sunshine coming in there. Okay, so 5 to the 5th power over 5 to the 2nd power. Let's write that out as exponents. So that's going to be 5 times 5 times 5 times 5 times 5 in the numerator. And then the denominator, I have 5 squared, so that's just going to be 5 times 5. Well, we've got factors here. We've got 5 factors of 5 in the numerator and 2 factors of 5 in the denominator. And I can factor common factors because we know that if I have a 5 in the numerator and a 5 in the denominator, 5 over 5 is another way I could write that. And when I divide 5 by 5, I get 1. So we can do that with these 2 factors of 5. Then we can take another factor of 5 and divide it out as well. So now we're left with 1 times 1 times 5 times 5 times 5 over 1 times 1. So that's 5 times 5 times 5 over 1. And that's the same thing as 5 to the 3rd power. So my shortcut, if I have 5 factors of 5 in the numerator and 2 in the denominator, I can factor out 2 of those factors. So when I do that, I'm really just subtracting the exponents. So that's going to be the same thing as 5 to the 5 minus 2. And that would give me 5 to the 3rd power. So it's all mathematical, factoring out common factors, and that's just a shortcut to subtract the exponents. If I do it in algebra, I would have b to the m over b to the n. They have the same base. So the shortcut would just be to say that's going to be b to the m minus n. So to divide powers with the same base, keep the base, just like up here, and subtract the exponents. Subtract the exponents. Down here, all I've done is I've done the reciprocal and put 5 squared over 5 to the 5th. Now when we do that, 5 squared is 5 times 5. 5 to the 5th is 5 times 5 times 5 times 5 times 5. And if I factor out common factors again, divide out a common 5 out of the numerator and denominator, there's 2 different ones. Then in the numerator, I'm left with just a 1. 1 times 1 is 1. And in the denominator, I'm left with 3 5s, so that's 5 to the 3rd. Now we know that when we have an exponent in the denominator, that's the same thing as writing a negative exponent. So we could also write 1 over 5 to the 3rd as 5 to the negative 3 power. So again, the shortcut works. I can take the numerator and subtract the denominator just like here, and do it down here. So that's going to be 5 to the 2 minus 5. And when I do 2 minus 5, I do get 5 to the negative 3. And that's the same thing as 1 over 5 to the 3rd, just like I got when I factored out common factors. So over here, if you notice, I had b to the m over b to the n, and I took that out. So now if you'll write it in as b to the n over b to the m, just because I flip-flopped them here, so I'm going to do it here, that's going to be equal to b to the n minus m. So it's always the numerator's exponent, subtract the denominator's exponent. And sometimes when you subtract, you're going to get a negative exponent. And that's okay. That just means it's going to be, if you want it to be positive, you're going to take the reciprocal. And again, it's the same words. To divide powers with the same base, keep the base, and subtract the exponents. All right, the last one you've already seen before, raising a power to a power, but I'll go through it again. So on this last one, if I have 6 to the 3rd power to the 4th power, then I'm going to take inside the parentheses, I'm going to take that 6 to the 3rd power, and I'm going to raise it to the 4th power. So that's going to be 6 to the 3rd power times 6 to the 3rd power times 6 to the 3rd power times 6 to the 3rd power. And then I could write those out if I want and say that that's 6 times 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 6. I'm just expanding what was in the parentheses, 6 to the 3rd, times 6 times 6 times 6. And those parentheses mean everything in the parentheses is multiplied. You could put a dot, but you don't have to when there's parentheses. Now if I count them all up, I have 3, 6, 9, 12 factors of 6. So that's going to be 6 to the 12th. And the shortcut, if I'm going to take 6 to the 3rd power and then carry that to the 4th power, the shortcut is to just multiply the exponents. So I don't have to write all this out. I can say that's 6 to the 3rd times 4, because I'm going to take 6 to the 3rd 4 times. So instead of adding all these exponents up and saying 3 plus 3 plus 3 plus 3 like we did up here, I could just say 3 times 4. And that's going to be 6 to the 12th. So over here, b to the m to the n power, raised to the m power, is going to be b to the m times n. When you're raising a power to the power, all you have to do is multiply the exponents. And then in words, to raise a power to a power, keep the base and multiply the exponents. Okay, so what I'd like for you to do now is we'll do a couple practice problems, and then tomorrow when you come in, we're going to actually do some of these problems in class. You'll have me there to help you. Okay, so if let's extend that page. Let's say I have x to the 3rd power times x to the 5th power. That's 3 factors of x and 5 factors of x, and they're all multiplied together, so that's going to be 3 plus 5, which is going to be x to the 8th power. And you can just put these problems back on your paper. You probably have some room here if you want to do it like right in here, that example, and then we'll do a couple examples right here. Okay, so if I have x to the 4th over x to the 1st, that's going to be x to the, and you can pause and do this yourself and then come back and look, but that's going to be x to the 4 minus 1, which would be x to the 3rd power. Let's say I had x to the, or let's do some other variable. How about we do m? M to the 0 power over m to the 9th power. Again, like basis, I'm just going to subtract the exponents. So that's going to be m to the 0 minus 9. So that's going to be m to the negative 9. And that should make sense to you because m to the 0 power is 1. So that's really just going to be 1 over m to the 9th. And that's the same thing as m to the negative 9. You can write it either way. All right, so if I look at this last one, let's say I do x plus, no, sorry. Let's say I'm going to do 7 plus 3 to the 4th power, and then I'm going to raise that to the 5th power. So first of all, inside the parentheses, I'm going to do 7 plus 3, so that's 10 to the 4th power, and then I'm going to take it to the 5th power. So that's going to be 10 to the 4 times 5, which is 10 to the 20th power. Now you may say, Ms. Stevens, why didn't you do exponents first? Because parentheses comes first. Remember PEMDAS? So you do inside the parentheses, and then you do the powers. And so I'm raising a power to a power, so all I have to do is multiply the exponents since I really have a like base. Okay, so you've got those notes. You've got the examples. So bring that in tomorrow, and I'll just check and make sure you did that. And as you walk in the door, okay, if you shake my hand with your left hand instead of your right hand, no, I tell you what, let's not shake, because people who didn't watch it will be like, let's just bump. But you have to bump with your left hand to my left hand. If you bump with my left hand to your left hand, or your left hand to my left hand, I will give you a prize ticket. All right? But it has to be left to left. All right, have a good evening. See you tomorrow.